Hey guys, not so much an update as it is part two of the first iteration of where we're at as far as the animation system goes. Now, I kind of suggested in the first video that eventually we're going to be converting everything over to hopefully what we'll call the black box or whatever that controls the overall movement of the character within three-dimensional space. Now, the ideal behind it, well, let's go ahead and just start with a kind of a simulation of where we're going. Now, I've included the tri-mesh that we used with some degree of success in 4.1/2, except for the fact that it was on a separate channel which was causing problems, and of course the mesh exploding, which is difficult to kind of describe. But if you think in terms of a sea urchin, the arms and legs were fine and the head were fine, but the torso selection had come unglued from the model, and it was all spiky and stuff. It looked like literally like a sea urchin. So that would explain a lot as to the problems that as to collision or hit detection being a major issue, so to speak. But that was of course we kind of fixed that off into 4.2. But the tri-mesh idea as a design idea actually worked pretty good. Even in intake 3, I was fast, and we're talking about 0.7K as tris count, not poly, tris. So that's like 400 or so in polygons. So from a concept idea, it was brilliant. Unfortunately, implementation kind of failed over time. Lord knows how that happens, but we all know things tend to go bump in the night when you start messing in one area, and problems sort of pop up in another that is totally unrelated. But I thought it'd be a good time to kind of re-examine it, re-examine the collision mesh idea, because it is part of the component of the player itself. So future-wise, just to kind of harp on it a bit, it's for a first-person shooter like ours, it's a good idea to stick with the player models with the same amount of volume and space. Like in 4.2, predominantly the female character obviously is being chosen as the player preference because of the illusion that because the player has a much, let's say, shallower silhouette at a given distance. It seems to have an indication that there is a distinct advantage between male and females, when in reality the collision mesh is the same for both male and female in 4.2. So you're shooting at pixels, pretty pictures with painted textures onto it, but the volume of space is still equal between the two of them. And since there's no such thing as really as distance as to relative scaling, then there's no real distinct advantage between the two. But of course you can't beat the psychological aspect of well, it looks smaller, then it must be smaller. So that's where the advantage does come in. So for HD, it's going to be rather important that we keep everything kind of standardized as to volume of space being consumed by the player model, particularly in the area between, say, male and female models, to ensure that there doesn't we don't create a bias between one. I mean, it'd be nice to see a much broader range of characters, but of course we have to kind of keep in mind that we are an FPS. So even though we have a desire for somebody to play with a particular toy of ours, then that becomes a moot point when you're talking about the psychological advantages that are available just by visualization and of course by sound. So that being neither here and there, we've talked about creating different types of size differences between one character and model and another. Smaller, larger. That's a great idea if we were an MMO or something like that, but being an FPS, we got to keep in mind that first and foremost, there's a level of expectation as to let's say, a ready-to-use model. In this case, beefing up or making sure that the character, the player model, as it is visually represented in three-dimensional space, is equal to one another, even if we have to kind of beef it up. So Sarah, being female, obviously has bumpy bits, which creates a much more, let's say, shallower silhouette, say, from the male player models. So we want to try to avoid that kind of selection choice based on misperception. So when we get down to actually finalizing the player models, then we need to make sure that they keep their the females keep their curviness, and the males, of course, maintain beefiness. But we got to kind of beef up the females a little bit with padding, so to speak, to equalize the volume of space as far as the silhouetting goes. So I just thought it's rather important to point that out now, so we can sort of content-wise, we can build that into the content pathway. So if Sarah's looking a little bit thin as compared to say Tom, then let's put on some floaters, some bling that will kind of build her out a bit, not necessarily make her look deformed, but kind of give her that kind of same silhouette. So if we, for example, just give her an all black texture, then she silhouettes at the same as in volume and space as say Tom, who's going to be much more beefier. So as for the black box idea, at the moment, well, I've added some of the basic key bindings that we expect that we will need based on 4.2 as far as action type events, and I'm going to be using montages for now, as we can tie those in later on, so that the player is committed to a certain action. So, for example, we have reload. That looks pretty but the reloads are going to be based on a particular weapon. So this is not a reload that is in any sense of the imagination conforms to the functionality of the M4. So that's the idea, is ultimately that functionality will be based on weapon use. So in the M4, you'll have drop the mag and two-handed reload, as in taking the mag up from the hip, inserting it into the chassis, locking it, and then cocking it with the right hand kind of thing. So it's going to be a much more accurate representation, both time wise and so forth. So a time penalty for reloading will be based off, obviously, on weapon use. So we won't go super slow. This is a good speed. So something kind of balances out, but there'll be a slight penalty based on weapon as to the speed of how fast a player can reload the weapon, and we'll go from there. Okay, what else do we have here that is functional or sort of tied in? We have that's the equip. Now, okay, that's we're kind of keeping everything vertically and horizontally, so it doesn't look as natural as it should. I'll get to that point in a minute of movement control, but it's this will do the job. It doesn't look cool, but once again, lessons learned in the past: keep things simple and vertical and horizontal as far as movement goes. I have some basic binding. Okay, grenade toss. Obviously it doesn't. We're kind of on the side here, but if we move towards the direction that we're normally be running in, it's a little bit more natural. A little bit more fine tuning as far as weighting overlap goes as far as the additive animation is concerned. Okay, so band engine is tied in as an event. Medicate is tied in as an event. I have taunts, they're kind of tied in as an event trigger. Okay, I think that kind of covers everything. Okay, just to kind of take a look at how things move. Let's go ahead and hide that, hide the mesh now that I've kind of covered that as far as. Ooh, it's raining. A little bit of ambient sound. Okay, we'll go to our character and we're going to hide that, hide the tri-mesh, so it's not kind of demonstrate what it's going to look like once we actually get it functional. Now, the idea behind the tri-mesh, of course, is we just have to cast a ray and detect the material surface, the name of the material that's been applied to a particular section. So head is red and it has an ID of, say, I can't remember off the top of my head, but let's say it's 4. It just has to respond with the, the material ID. So it says material hit 4. So obviously we've had experience about things like ordering, mesh ordering, where a ray is traced is struck, say for example on an arm, hits a torso behind it. You know, we know the fans of our game like to have the higher value target as opposed to, you know, hitting arms. You know, the idea behind it, of course, is we order the depth of the trace between the higher value surface struck versus the lower value. So you know, something that is struck from the front hits an arm, which would naturally, if we're talking about realism, would naturally cut through the arm and hit torso. So we give them, we have the option to give them the higher value result. Maybe I should turn that off. Just give me a sec. Okay, that's the heater. Okay, so let's kind of turn that off. Okay. Whoops. They, as always, with an update, they do tend to change the. They do tend to change the layout. I liked working on the left side, and then in the update, everything is put over to the right side. But okay, so anyways, as you can see, we got it visible, but we can hide it in game. So as long as as long as it's visible. So if it's invisible, it's invisible. If it's hidden in game, it's hidden in game, and it doesn't basically exist. But if we keep on visibility and hidden in game, we can still see it in our our port here. But when we go ahead and play, you can see that our tri-mesh is now, or our tri-mesh has disappeared, but it's still there, so it can still be struck. Okay, movement wise, I fine-tuned it a bit, so the requirement of experiences learned is to keep the head on the vertical, so that it's always in position relative to, obviously, to where it moved off of. So you know, they don't like the the swinging of the body weight from one direction into the other. We can always add that later on in the future if we want to. Okay, so we go through the walk. You can see that the head is pretty solid. You know, there's very little opportunity for it to swing off. It swings off a bit, off a center, but it's not warping, which would, because of the interpolation between one position direction changed into the other, which has always been a nightmare to deal with as far as id Tech 3 goes. So you know, that's just something that's built up over the years as to expectations of the players expect as far as movement goes in using id Tech 3 and 4.2. So we go to the crouch position. Head once again stays on the vertical. It doesn't have that natural look, but you know, first things first. You know, get it to where it needs to be, and then we'll worry about adding in any flavoring later on as far as the lower torso goes. So the hips kind of stay. I've changed that too as well. You know, in the first iteration, the butt was swinging around into the different directions, which added a little more liveliness to the player, but at the same time it was kind of off-putting as far as what would or could be considered an advantage. So okay, so anyways, we're discussing the idea behind black box control now to kind of build on that concept a bit. The ultimate goal really is to make the player model environmentally aware that you know, if it bumps into a wall, where is the wall located, how high it is, and how it reacts to those types of let's say obstacles. And so that's going to probably involve some form of physics, and I've yet to actually look closely at creating a physics character attachment to the character. So this is obviously going to be involving something in that area, but there's some form of AI that we can add onto the character in such a way that it's all driven through a black box that drives into a single, hopefully a single movement system. So as a logic, we're kind of in the make it and break it phase right now to figure out exactly how we want to be able to have the various different components. As we all know, Unreal 4 is very modular in design, and so it gives you a much broader range of options of how you can create the type of control systems that you want, based on normal logic that was really not available in any other engine that I'm familiar with, at least, as far as making the player react in what would be let's say an expectation. So the first starting point is using blend spaces. Now blend spaces are actually kind of brilliant in that they allow you a fair amount of input type of control based on a given event. So you know, I have key bindings that I've set up so far. They don't, you know, I spend a lot of time to prevent them from creating any kind of bounce. So so if you know, the normal habit of changing directions, of course, is you hold the key while you select the next key and then release the first key. So you know, that's an up-down event that kind of chattered the animation at first until I figured out how to prevent that from happening. So you know, you can change directions without having to remove your finger from one key A to hit key B that caused the animation to jitter. But that everything is, as far as key control as to direction, is done in a blend space. -1 to 1, which of course left and right, forward and back, which corresponds of course to an event presented by a key being pressed. We are a PC game, not a console, so you know, we're going to be using keyboard controls. So they're either on or they're off. There's no velocity to a key, obviously, which makes it difficult to input, say, a velocity of a mouse. To demonstrate that, let's see. Let's go to the aim offset. Okay, here's our aim offset, which is conformed to fit, let's say, the idle of the character. Everything kind of starts with the player not doing anything. They take their hands off the keyboard, they take their hands off the mouse, and it will rest at idle. So this is kind of the aiming kind of setup we have so far for that kind of position. And as you can see, it's dynamic and linear based on the digital input values based on the mouse, which has created some some of its own little problems, which I won't get into at the moment. They're just problems to deal with. You know, nothing disastrous. Okay, so let's get back to running and crouching here. Everything has been put into the blend space as far as character movement goes, left to right, forward, backwards, as well as into different directions. We are a strafing game where, you know, the character does have to move off angle from the center position. So we got 8-way movement control here, as well as at the moment 3 depths of movement. So dead center, idle, will always default. The player model will always default to idle, to this idle, the preferred idle within the blend space. But anytime you hit an event, then that event is either -1 or +1. So we start clamping stuff off. So if we know that, okay, we have a plus a 0.5 and 0 on forwards and backwards or right or left, then that's clamped to whatever current movement mode that they're in. So if they're crouched and moving forward, then they're clamped to this value here within the blend space. And then they start walking, that moves them off even further. And then if they're running there, then they're at the full 100% unclamped region of the blend space, which moves basically from one end to the other. Now, as far as controlling the character go, this is somewhat limited to a particular section of the body. So we obviously have been aiming for the torso versus movement for the legs, so that creates a division between the need for 2 different types of blend spaces. But if this was thought out a little bit more down the road, to think of it more as being able to lay it out as a much more common type of blueprint usage, as to creating out, laying out a grid. You can put all of your movement controls into a single blend space, and then control everything with a black box and mathematical inputs, and telling exactly where it needs to be, as well as the ability to be able to cross over from one end, interpolate from one end of the blend space to the other. So you can see that there's, even with the crouching, there is a kind of a changing of the weighting. So you could have, instead of just one single blend space, or a bunch of different blend spaces, it would be nice just to have one set up like a blueprint on the grid. You define your volume of area space that says, okay, this is for running, this is for crouching, this area is for this, and this is areas for that. So you're not jumping around between 5 or 6 different blueprints just to get what you can get on a single blueprint, and then we just sort of interpolate the speed differences between the different requirements. Like all this here, stuff over here is exposed to blueprints, so we can change the weighting and so forth that way. And it would be nice if we could just have a grid, and we could say, okay, if we're going to change directions, instead of going from this point here to this point, I think I've discussed this in the past. If we can go from one end to the other and cross over the blueprint, then we can put all our body weighting into one nice little package, and we're not going to be, we can keep that vertical line without everything kind of popping out all over the place, and it won't look like it's, we have that body-torso connection. Obviously, we need to, I need to fine-tune that a bit more to get rid of that refrigerator running around with a gun sticking out of it look. So, we need a little bit more body weight changing, but not a whole lot. Okay, so that brings on to the idea of being able to. Actually, what I'm going to do is I'm going to go over where I'm at so far as creating the system goes. The fact that I'm able to do this at all is a miracle. So that's really a testament of just how well, from a logical standpoint, it is to figure this out. At the moment, though, as I say, it's break it to make it. So to go over to kind of how things are kind of set up for now, just to get it working, so we can kind of isolate it. I'll go over to how structurally the blueprint, the actual animation blueprint is configured. Let's go to the anim graph to begin with, and then we'll go from the anim graph. Come on, Mr. Anim Graph. We'll go to the locomotion section here. So very simple. Everything goes into the idle state, which controls, which is the obviously the default position of the player model, which you see kind of looks different from this here. I'll get into that in just a moment. And then from there we can go into secondary events, like for example idle crouch, and then it goes to the crouch idle, and then from that position it can move off into and blend into the run crouch state based on a clamp value. So if the clamp value is 0.25, for example, it knows it's crouched, and we just have to maintain the flow of the pathway based onto it. So for example, we can't move back here. Not is moving. If the player stops, is not moving, and is not crouching, then it comes back across this pathway back into the idle state. Then we can also move off into the sprint loop, and of course if we're not moving, in other words you're just sprinting, you have that that's the idea too as well, is even in the crouch position you can move into a sprint, and then it says, okay, is the player still moving? No. Then it can is it in a crouch? Yes. Then it can come back into the sprint idle position, or even back into crouch moving, and so forth. So everything kind of flows around one another. Events like turning left and turning right can be stemmed off of the or forked off of the idle state. They're just a changing of directions. So you know, something to play around with to actually get the right kind of turn. Right now it's kind of, you know, you're either it's, you know, somewhat of a drastic turn. So probably land up with feet stomping. You know, as the player turns while they're idle, they stomp their feet like they did in Tech 3. You know, we're we're going to try to bias more towards what would be considered realistic, not so much as to realism, but we'll bias towards making sure that player movement is not inhibited. We're not creating an artificial lag or you know, a false sense of oh, what's the word? Never mind. Anyways, so we go from the stop into the idle state. Now, depending on the state, this is modified externally through things like forward, backwards, and yaw, minimum, and maximum controls, as well as part 2 of the requirement is the type of weapon that the player is using. That we apply a we can apply values to. So for example, everything will be kind of rotate around obviously the idle state, as well as a connectivity to a particular weapon. So oh, there it is. I've created a weapon index. I'll talk a little bit about that in just a minute here, but the weapon index will then it is inputted based into the character model based on to the oh, hello truck, is based on a fixed value. So for example, we don't have to worry too much about making sure that everything is kept in an orderly manner, but rather being cautious about applying a index value to the weapon itself that can be picked up by the character, which then will conform to that particular type of configuration. Just to kind of demonstrate it a little bit here, I have a few things set up. So 0, is it actually functional? Okay, 0, 1. You can go see, we could go to a sidearm, back to a rifle, back to the sidearm, to two-handed dual weapons, and those are the kind of proxies I got in right now from make it and break it. To make it to, we have to first break it standpoint, and then we can go back to 0 again, which then will register the different shape as to without the need to re-author, let's say, a complete set of different animations to conform to the weapon. So if we're doing the sidearm thing, Yeah, somehow. Okay, I probably still have that set up as needs a little bit more fine tuning there, obviously. So if we have it set up as a side on, for example, and we start moving, can I just go ahead oh, we won't go too deep in that. Just imagine that all this stuff here then comes into play as far as the shape goes, and it'll be a little bit more apparent when we move forward. Okay, back to the anim graph here, how things are set up. I'm pulling in the character information directly from the character itself. This is going to have to be changed, obviously, because of the different player models. But you know, I want this to be data driven, so we're not having to change. You know, each character is going to have the same set of data, but we obviously want to have at the beginning some form of level of degree of flexibility of being able to apply, let's say, differences between, you know, we were talking in the past about making you know, bigger guys slower and smaller guys like without vests and so forth faster. So everything's kind of being channeled through the proxy at the moment, and then I just set the pawn and set the output characters needed for the different areas that we need to draw that information directly from it. So obviously things like these things here, well, they work and might not be the most ideal, but something that I've discovered is you have to kind of make a call to the character that's being cast from. You just can't draw from it once. You have to have a setup where it's constantly making a call to the character as to the information that's needed. So right now I'm using a function, probably a macro or something where I work with that, because there's a lot of information that we have to make a, let's say, a request from the character. So I'll have that kind of just set up that in a, let's say, make it work kind of fashion, which pulls out the information from the character. Is it is the keyboard saying it's walking, is it sprinting, or whatever. Unfortunately, the a bit of an annoyance is an animation blueprint apparently cannot directly control event inputs, like what key was pressed or which way is the mouse pointing. It has to be bound to a player character blueprint as far as input goes, which, you know, in a way is kind of logical, but at the same point it's a little bit frustrating when you think about our requirements that all players have to have the same control, they have to have the same physics, and they're just you know, it's just a model with a different paint job onto it. So you know, this is the way we got to kind of go. Probably not the most ideal. I'm learning as I'm going, so you know, if anybody wants to make comment on that as to a better option, I'd be more than happy to listen to it. Yaw and pitch control, of course, is something that we have in place, so to be able to these are controlled by minimum and maximum input values. So the animation, of course, itself is at an extreme. So once again, ideal-wise is to make the player model much more environmentally aware of where they are within three-dimensional space, and then have the black box allow the to restrict movement based on inputting into a fixed value into a blend space that prevents some of the annoyances that obviously we don't like and, and have seen had to constantly live with. So this is a good starting point as far as being able to control the actual limits of, say, pitch and yaw of a given situation as determined by the environmental space itself. So we'll get to that in just a minute here. Okay, so we'll go back to our event graph here. Okay, and I have this is hopefully be all put into I like to put these all into a macro or something like that to keep everything kind of nice, clean, and tidy and focused on where it's supposed to be. Yeah, that's a lot of information looking on the screen and trying to figure out where things are. Where, you know, if we keep things in nice little macro packages, it'll help whoever has to work on this in the future, because obviously at some point when we start getting into the physics nature of it, somebody else with better math skills than I am going to have to become a little bit more involved with this. So anyways, here we have our yaw setting as far as run and idles go. Okay, you know, we're talking about in the past about alt aiming. So this is where that kind of takes place between if you stop running and you're not moving, then you have, we want to give as much freedom of the player being able to aim where they want to aim, and that's where the obviously we also talked about in the past about creating a much more tighter connection between the player model and the third person and the third person. So this is where this kind of comes in. So wherever the player is aiming as a first person, that's where the third person player model is aiming to as well. So we are also talking about scoping. Some have asked that question about what the hell is scoping. Is obviously we have sniper rifles, the SR8, where the advantage goes to the player who uses it because of the, well, the other need, of course, is the player always has to be aiming. That's almost a demand. So we got to make sure that that gun is facing down range within a scope of percentage difference between firing and actually just kind of running. It kind of looks goofy, but that's we're not realism. We are fun over realism, so got to keep the gun pointed downrange, so there's a clear indication of where the player is pointing and what direction they're headed into. It's just logical, and that's just the way it is. But when they're running, we have the alt ability, which allows the player to kind of aim while they're running at say at least a 90-degree angle from another player, so they don't have to strafe into the other player. They can take tactical shots, like for example the alley in Casa, where where you got to kind of turn into the direction, and then you got to kind of strafe sideways to the alleyway instead of running across it, where you can just you can just alt, and you can change your aim direction without having to worry about your direction changes, kind of confusing you. So you can turn to the right to get that alley shot, and then keep running forward, and that will add a little bit more advantage. But when it comes to scoping, the SR8 had the advantage of always being aiming down range, which you couldn't, where there also is a need to be able to tell when a player is not aiming. So it's an unfair advantage that a player with an SR8 can be just standing there without using the scope and looking around, and it's the same kind of positional kind of pose that's the same as if somebody was using an LR and M4. So if they're sitting there and they're and they're just kind of looking around and being a tourist, that weapon has to come down to a point where there's a distinct difference between them actually aiming and looking through the scope versus them just kind of being a tourist and looking things over, kind of thing. So that's going to be kind of a twitch thing. It's not going to be like drop it down to to a much more natural idle. Who knows, maybe we will do that. If they're going to sit there and they're going to look around and explore, it gives the guy on the other end the opportunity to know when they're changing position. Are they actually changing position without using the scope, or are they changing position using the scope? So that's an annoyance of mine. Let's say I'm fixing that as an annoyance of mine. We'll figure that out obviously through the course of testing, Q&A. They're doing a damn good job, and I feel comfortable with the idea that we could just leave those kind of things for them to kind of figure out. Okay, event triggers, kind of messy. I gotta stack this in. As you can see, we do have the ability to put things into a matrix, into an array. So eventually, I would like to tie this all events into a single solution, because everything in this area here is all grouped in as actional type of a event. So over here we have like bandage, equip, reload, medicate, grenade, and taunt. These here is the firing modes for single shot, burst, and full auto. These are all tied into a montage, and at the moment well, some of these things have to be tied in as one-time events. Kind of look at the problem we have right now, which is not drastical. I just haven't got around to fixing it yet. So if we do a reload, we can keep cycling through the reload. So we got to kind of lock that off so they can only hit the reload once, and then if they want to reload after that, they can't reload because they got a full load. They fire one shot off, boom, and then they can hit the reload again as to expectations of how things are done now. So that's not registered in at the moment as being that kind of a type of event. So as far as montages goes, I'm going to have to kind of over time, once again, we're just at the stage of just making it work and then figuring out how to make it better later on. So everything's done in sequences and so forth. Keeps sequences nice, keeps things nice and neat and tidy. Nothing says that you have to kind of tack things onto in the end and one another. What would be nice though is a routing node, as into the same idea as to how things are done in the atom graph, where you can cache the information and then use that as to being able to input it into a different location. That way you can, more or less, if you wanted to, you can create individual boxes up here without these lines tied in. As it is, if I didn't do that, we'd have all these blue lines going all over the place. So it can get really complicated really fast. So rule number 2, I guess, as far as designing it goes, the need to maintain. Rule number 1: maintain the consistency of the player models as to volume and space that conforms to the character rig, without having to rebuild anything else or author any other elements, and just kind of recycle everything from by conforming it to it. Okay, so I think that kind of covers. Okay, we have some. Haven't done much with the IK. Did some experimentation. It's going to be a lot more, let's say, technically, some technical requirements that have to be kind of solved first. Here's the clamping values I was talking about as far as going into the blend space goes. 0.25 is crouching. 0.5 is walking, and 1 is, of course, is by default is the maximum clamp value. So I like to, if possible, keep everything into one blend space, and then we can just feed the information, because in the end I think that the actual movement control, as I mentioned before, the ideal of it all is to make the player model let's say AI aware of its environment and behave in much more of a procedural manner rather than being directed by key input, solely by key input alone. And I'm going to touch onto that in just a moment. So anyways, here's our atom graph, the way I've set up. Where I basically take everything in and cache it as a starting point. And from there we move into the weapon selection. Now this is where things start to tie into the idea of weapons overriding posture, so to speak. And at the moment, this is going to take some rethinking. I want this to be slicker than it is right now. It's kind of let's say has the potential to get fat really fast. I would like to maintain as much as possible everything to a nice clean package, but as I showed you in the event graph there, how the weapons can change. You can see we can change and add those poses on as an additive blend pose by value. So if we change the value of the weapon, it changes the blend pose as a given event. And then of course this translates into to action. Okay, this translates over into our action events, which once again is kind of make it work kind of make it work phase. So all of these, I hope, since they can be value driven, would be to input these in through a montage, a single montage event based on a particular weapon being used. So things like grenade toss, attack, and rifle equip can be all done on a single track. But we're obviously going to have some events that are going to be bound to to the particular model. So since these are montages, for example, the attack ones is an absolute as far as I can see of adding on the same attack that is applied to the enforce. So we need to be able to have a couple of different key poses. You know, the weapon, the player model with the weapon in the idle state, the player model with the weapon in a firing state, and then build up montages around that. Dual. You know, I've got that kind of position, but really haven't thought about it to any kind of extent. So we have our dual kind of configuration. Need to give that some thought, because there is going to be a left-right firing mode, and of course reloads are going to be a lot more complex as far as having to deal with two weapons goes. So from this stage here, we go into our final, which is our final output is a blend space offset. I'd like to try to keep a single offset, and then just offset that with the dual hand pose here. Now it does kind of work as far as inputting a posture through the weapon selection. So I'd like to get a little bit more finesse, let's say. But that's something down the road. Then we go into into the final mode, which is the bone eye case for feet, and eventually for locking hands and so forth. So this area in here right now is kind of in the experimental stage. Because we're going to have to be casting a lot of rays and so forth. So that brings us back into our scene as to expectation as far as the idea of, let's say, the player model actually being environmentally aware. So this is obviously going to have to involve some sort of physics, and I haven't played with the physics system just yet, but everything is has to fit in the volume of space that is defined obviously by the capsule. So as we move forward, the capsule, you know, bouncing off the wall, but we still have this brutal type of look of the weapon being clipped through the wall. So I think we can probably solve that by adding a physical limitation to it. But I'm thinking that you know, we can add something that we haven't done before, is add an intelligence, a level of intelligence to the weapon itself, of actually telling the player model that it's in a position that is unacceptable. So this position here would be unacceptable versus, you know, okay, I'm going to push you back. So okay, you like going on the wall? No, I'm going to push you back. But if you go in sideways or whatever, then you can get closer to the wall kind of thing. So there's no collision. Or even in this position, we were talking about cover type of animations where the player can kind of spin around and back up against the wall. As long as that barrel is kept out of the wall, then that would be acceptable. Now that also changes the idea of how we've have 4.2 set up, which is probably the same way that all games are set up, is that the shot is projected from the head and not from the weapon itself, but from the muzzle as an expectation. So this tends to also require that the rifle is held in a aiming position at all times. One of the things that you know, you got to start putting in animation-wise, you got to make things a little, let's say, to make things look a little bit more natural, you got to start putting in player latencies, which is you know, is along the same line of thinking as what realism would be. And you know, if you're out hunting duck with your shotgun, and you have that normal carrying post, and then of course when you see the duck, then the event in your head is triggered where you're bringing the rifle up, and then you're aiming and you're firing, which is doesn't work well in a video game. You know, you press the button and then you have to go through this cycle before you're actually firing. Is a player latency, which we need to avoid, because the moment they hit the trigger, the shot is fired. So what you have in that pose is you have the muzzle flash, the player finally coming into the final pose before firing the second shot, if there is a second shot to be fired, and then going back to that pose again. So once, as mentioned, everything has to be based off of this idle pose that we have set up, and then you know, and then wedge it from here. You know, are they just kind of running down, or are they actually aiming? So but a must, of course, is to have a correlation, say a relationship, as I mentioned, between first and third person and barrel, wherever it's pointing, wherever their head is, regardless of where their head is or where their visual is as far as third person versus first person model. It has to kind of match up. So if in, you know, this is not natural, and what I'm thinking is we put some smarts into the weapon itself as to be able to apply a logic to player movement. As I say, ideally the entire animation is driven by a procedural event, aka black box, which determines where the player is in relationship to in real world space. So if we're over here, for example, when the shot is fired, the ray is traced from the back of the stock to and through the muzzle of the stock. So that way, if they go into a crouch position, you know, if that muzzle is over the ledge, they get the shot off. If they're aiming down, their shot goes into the wall. So wherever they're aiming is that muzzle is pointing is where the shot is projected. So couldn't do that before because you couldn't script anything into the engine without any heavy decoding. But it's actually something that a content creator can quite easily do. As, you know, when they figure out how to do a ray trace, it can just project a trace, like you know, how I have the feet set up here for IK. You've got a red line that comes right out of that muzzle. If it hits wall, you're shooting, you know, you're shooting in the wall. But you shouldn't be able to rotate down this far to begin with. So if you're looking over top of the ledge here, the AI is always monitoring for that collision. So if we bring it down to here, it says nope, can't do that. It locks the yaw off. So see, in I'm just hands-off idle state that the yaw is, or the pitch, I should say, is coming down a little bit too low. So that pitch needs to be maintained at a higher, at that level. So if it tries to go down, boom, nope, you can't bring the yaw down. Boom, nope, can't bring the yaw down. Same with over here, you know, you can't penetrate the wall. So we can put the AI and the collision and overlaps in the weapon, and you know, it says, okay, whoops, you're too close. It pushes you back to where the muzzle will allow you to rotate and pitch, but still can move into the wall based on the collision in the capsule. But then if you try to turn this way, the yaw is limited. So that is hopefully the end result of of my design idea. I think you know, I covered everything that needs to be covered at this stage here, but just to keep you guys up to date as to what I would like to see. So those of you who have math skills can start working on a black box solution. You know, I think I covered everything. Good enough. Later.